Okay, so we are officially going to be proving something is a parallelogram, and we can do that in one of 5 ways. First, if you can prove that both pairs of opposite sides are parallel, that is the definition of a parallelogram. If you can get both of these opposite sides parallel, it is a parallelogram. Now remember, in order for sides to be parallel, you have to know some information about angles. Okay, so you have to know that, consecutive angles are supplementary. If this diagram was drawn differently, you can have alternate interior angles are congruent, then the lines are parallel. So that's the first way. Second way, if both pairs of opposite sides are congruent, then it's a parallelogram. So if you can prove to me that the top and the bottom are congruent and the left and the right are congruent, then you know that it is a parallelogram. Third way, if one pair of opposite sides are both parallel and congruent. Okay, so this is what that means. If you have this pair that's congruent, that is the same pair that has to also be parallel. Okay, if you have this pair that is parallel, again, you have to have that same pair that's congruent. In other words, it cannot look like that. You can't have the left and the right congruent and the top and the bottom parallel. That does not work. Okay, so it has to be the same pair that is both congruent and parallel. Okay, my fourth one is if the diagonals bisect each other. Forgotten one. So if you can prove to me, and I'm going to add a point here. If you can prove to me that AC is bisecting DB and DB is bisecting AC, if they bisect each other. In other words, AE has to be congruent to EC and DE has to be congruent to EB. If you can get this to be true, then you know that this is a parallelogram. And my thought here is you would probably be proving triangles congruent. If you can get triangles congruent, you can prove those diagonals bisect each other. Okay? And then the last way to prove something is a parallelogram is if both pairs of opposite angles are congruent. Okay? In other words, if A is equal to C and if D is equal to B, then you have yourself a parallelogram. Okay, those are the only 5 ways you can prove to me it's a parallelogram. So I have an example here. Okay, I am given that A, C, D, F is a parallelogram. Okay, so we have all the attributes of a parallelogram. We know that the top and the bottom are congruent, the left and the right are congruent. We know the top and the bottom are parallel. We know the left and the right are parallel. We know that the consecutive angles are supplementary. We know the opposite angles are congruent to each other. We know the diagonals bisect each other. Now there's no diagonals in here, so of course I wouldn't be using that. But we have all that information just from that first given. We also know that AFB, we know that this angle right here is congruent to ECD. We know that these angles are congruent to each other. Okay, so that's going to give us some information here. And then they want us to prove that this smaller pink quadrilateral, they want us to prove that this is a parallelogram. So I'm going through and I'm thinking, how can I prove this is a parallelogram? Okay. If I can prove that both pairs of opposite sides are congruent, if I can prove both pairs of opposite sides are parallel, if I can prove opposite angles. Now there's no diagonals in this one either, so I'm not even going to go the diagonal route. I'm not even going to try for the diagonal one. I don't want to add in extra lines if I don't have to. Let's see, if one pair of opposite sides is parallel and congruent, so I can go with opposite sides being parallel or congruent, or I can go with opposite angles being parallel and congruent. Now there's tons of different ways you can do this proof. I'm already like brainstorming as I'm talking to you guys. In my brain, if this blue shape is already a parallelogram, I know that the top and the bottom are already parallel. So half of that's done for me. So I can try and get either the top of the pink, I can try and get the top and the bottom congruent to each other. And in that case, that would be the orange one. So I can try to go for that. Because I know, again, that the top and the bottom of the pink are already parallel, if I can get the left and the right parallel, like if I can get these parallel to each other, then I can use the first one if both pairs are parallel to each other. I can also go opposite sides congruent to each other. We can go that route. So there's lots of different routes we can actually go here. So let's take a look at this and see which route I want to go. So let's start building our proof. Statements and our reasons. The first thing I'm going to put down is that ACDF is a parallelogram. Okay, and that's given to me. So is there anything that I want to do? I'm thinking, so they gave me that this angle is equal to this angle right here. Parallelogram. So if I know that those two angles are equal, I can do the subtraction property and do the opposite angles if I wanted to. That might be some good information there using the subtraction property. Let's see. I know I can get the triangles congruent. Why don't we start? Let's get the triangles congruent to each other and see if that's going to help me. So I am going to get the triangles congruent because Miss Boutique always tells me to do that. So I know that these angles are equal to each other because those are opposite angles in a parallelogram. So angle A has to equal angle D. And my reason is if a quad is a parallelogram, then opposite angles are congruent to each other. So I have those opposite angles that are congruent to each other. I know that opposite sides are congruent to each other because it's parallelogram. So I have AF congruent to CD, and that is, again, if a quadrilateral is a parallelogram, then opposite sides are congruent to each other. And I'm going to use that next to given. Here we go. So AFB is congruent to ECD, and that is given to me. So now I have my triangles. Triangle AFB congruent to triangle DCE. Okay, and that is by angle, side, angle, side, angle. Step 2, 3, and 4. Excuse me. And now that I have those triangles congruent, I'm going to pull out this side is equal to this side. Let's see if we can go this route. So CPCTC, I have FB is equal to EC. Okay, so I know that those sides are equal to each other by CPCTC. I'm just a hot mess right now. Okay, so those sides are congruent to each other, so I have those pink sides, which is awesome. Can I get the top and the bottom to be congruent? Let's see. Oh, okay, here we go. So again, so here's what I'm going to go the route of. If both pairs, the blue one, if both pairs of opposite sides are congruent, that's what I'm going to go for. Then it's a parallelogram. I already have one pair of opposite sides congruent, and I'm going to jump back to, I know, look what I know, guys. I know that FD is equal to AC, don't I? Because if a quadrilateral is a parallelogram, then opposite sides are congruent. Opposite sides are congruent. And I also have my congruent triangles, so I know that ED is equal to AB by CPCTC, same thing as number 6. Therefore, FE has to equal BC if congruent segments are subtracted from congruent segments, then the differences have to be congruent to each other. So I have this blue segment equal to this blue segment right here, and therefore I can say that FBCE is a parallelogram if both pairs of opposite sides are congruent, and they are. I'm going to put that in step 6 and step 9. Then the quad is a parallelogram. So we have a parallelogram. Now again, there's multiple ways of doing this. I could have thought this out more. We know that this whole angle equals this whole angle, so this angle has to equal this angle. And then we have this pink blob equal to this pink blob by CPCTC. Then we would know that this pink circle equals this pink circle because supplements of congruent angles are congruent, and if both pairs of opposite angles are congruent, then it's a parallelogram. So there were lots of ways that we could have gone about writing this proof. This is just the way that kind of popped in my head. But again, there's multiple ways to prove each one. These are the only 5 ways, though, to prove something is a parallelogram.